Hello again. Today we are doing three forms of a linear equation. I've actually shown you one already. It's this one. But I didn't tell you what it was called. This is called slope-intercept form. And since you already know what M and B stand for, the name slope-intercept form probably makes perfect sense to you, since M is the slope and B is the y-intercept. Now, there are two other forms that are important to know. There is standard and point slope. Standard looks like this. So you'll notice this equation has an x and a y in it because every equation of line has to have an x and y variable. However, this time the x and the y terms are both on the same side of the equation as opposed to slope-intercept when they're on opposite sides. And the order is important. The x term comes first, the b term comes second. And the term that has no variable in it goes on the other side of the equation by itself. And, this is important, a, b, and c must be integers. Sometimes the coefficients of x and y are given as fractions, so you need to clear those fractions by multiplying by the denominator to make sure that both coefficients and the constant that has no variable are integers. So this is an example of a linear equation in standard form. 3, 4, and 12 are all integers. The x term comes first, and the x and y term are both on the same side. Now, why would we use this form over something in slope-intercept form like y equals 2x plus 4? Does this form tell us anything about the line? As much information as this one tells us, slope and y-intercept? Well, the answer is no. It doesn't tell us what the slope is. The slope is not 3, the slope is not 4, the slope is not 12. It also doesn't tell us what the y-intercept is. So that's a disadvantage that this has, and an advantage that slope-intercept form has. However, it does have something that slope-intercept form doesn't have, and that is, it is very easy to find the x and y-intercepts from standard form, because if I plug in a 0 for x, it's very easy to calculate y. Why? Because in standard form, this coefficient must be an integer. So if that's an integer and that's an integer, it's very easy to calculate y. If I plug in a 0 for y and solve for x, I will have found the x-intercept. And again, it's very easy because 3 is an integer and so is 12. So I can find the x and y-intercepts very quickly. Within 5 seconds, I'll know that the the y-intercept is 4, and the x-intercept is x-intercept. Sorry, 0.3 for the y-intercept, and the x-intercept is, let me get this right, So if I plug in 0 for x, y is 3. Yeah. If I plug in 0 for y, then x will be 4. So y-intercept 3 and x-intercept 4. I can get that very easily. It doesn't tell me the slope, but as I said in a couple videos before, if you have the x and y intercepts, you can graph it very quickly, and you'll have the intercepts already. Now, if you really want to know the slope, no problem. We can just transform the standard form into slope-intercept form by solving for y. That's my destination. So I would subtract 3x from both sides, and then divide by 4. Okay, this is the slope-intercept form of the exact same line. So I know the slope now is -3/4, and I know that the y-intercept is 3, but I already knew that from up here. Now how about transforming from slope-intercept to standard? Okay, this is not done as often, but it can be done with not too much trouble. So let's just take this equation, y equals 2/3 x plus 4, and turn that into standard form. So first of all, I need the x term and the y term on the same side, and the term that has no x and y on the other side. So I'm going to subtract 4 from both sides and subtract y from both sides. Okay, now I'm going to use symmetry and put this stuff on the left and put the -4 on the right. And the last thing I'm going to do is make sure I have no fractions, so I'll multiply everything by 3. And so slope-intercept has now become standard form. There's one more form I'll show you, and that is point slope. Now from the name, you can probably tell that there's going to be the slope in the form. So it'll be staring at you, just like the slope was staring at you from slope-intercept form. Now this word point is kind of ambiguous, but what it means is that in the form there is a point staring at you, and that point is x1, y1, x1 comma y1, here and here. The coordinates of a point are known and are staring at you from the equation. So for example, in this point slope form, 3/2 is the slope, and 5, 2 is a point on this line. I know that because 5 is in the place of x1 and 2 is in the place of y1. So I have more information staring at me in point slope form than I did at standard. In standard I knew nothing. I didn't know anything until I calculated something. But here I have the slope staring at me, and I have this point staring at me right there. What do I not have? I don't have the y-intercept, so that's a disadvantage. I don't have the y-intercept, I don't have the x-intercept. To find those, I have to do some work on my own to get them. Okay, can I transform this into the other forms? Yes, I certainly can. So if I want to turn this into slope-intercept, I can distribute this 3/2, and then add 2 to both sides. 2 is 4/2, so that becomes negative 11/2. So there it is, slope-intercept from the point-slope form. And if you want, you can go further and turn this into standard form, which I already showed you an example of, so I won't do that right now. Okay, there you have it, the 3 forms: slope-intercept, standard, and point-slope.